Greetings! I've updated the block diagram for my 10 GHz transmission system, and I thought I'd do a recap with you just so that you understand where I am with this project. So this part, DLO, this is probably the part I worked the most on, and I finally nailed it down, and the ADF 4351 synthesizer chip will work very well. I'm pretty sure it'll be fine. It's fed by a 10 MHz OCXO. I've added the levels in dBm. Remember that 0 dBm is 1 milliwatt. And then it's how many dBs above and below 1 milliwatt. So we're slightly more than 1 milliwatt here. Into the W1GHZ tripler board, which has these stages. That's known. We've seen that before. We come out at 10224 at a level of plus 6 dBm, which is just enough for our mixer. Plus 5, plus 4, plus 5, plus 6, plus 7. It's going to be happy. I'm going to use a low loss cable here to make sure I don't lose too much. This is the W1GHZ transverter. What I've done is I decided to reproduce the transverter but separately so that we see what stages are where inside the transverter. But we've seen what it was before. Two separate branches, 10 gig receive, 10 gig transmit, a splitter, and a double balance mixer that takes the IF or provides the IF out, 144, and takes the LO at 10224 gigahertz and produces the RF, right? Okay, now back to the upper part. We said that we were receiving our LO. The IF path, it's bidirectional as shown. I'll be using 500 milliwatts in transmit, so that's plus 27 dBm. Plus 30 dBm is 1 watt. Plus 27 is 3 dB less, and 3 dB less is half the power, so 500 milliwatts in transmit. Remember that I have this attenuator here that is by default inline, and in receive it gets removed and the transfer relay bypasses the attenuator. So in the transmit path we go through 30 dB of attenuation, so a factor of 1000 down, so 500 milliwatts divided by 1000 is minus 3 dBm. So it's 30 dB less than plus 27, so it's minus 3. And minus 3 will make this thing happy. Mixed with the 10224 gets us at 10368 in transmit. We have our power amplifier, which you've seen in a previous video. It has a gain adjust potentiometer that I will adjust, so that minus 8 puts out the roughly 3 watts out, plus 35 dBm. We have an external coaxial relay, SMA relay, into the antenna. On the receive path, relay will be transferred over to the receive path to our low noise amplifier, the one I recovered from a DSS TV dish, into our splitter and into the mixer and out to 144, and in receive, like I mentioned, the attenuator is bypassed and it goes straight to the receiver. So that's pretty much how the system will operate. So what's next for me? Well, integrate all of this into the dish, the rear compartment. But in order to do this, I need to think about the power distribution, which voltages are required, at how much current. And this is going to be the subject of my next video, power distribution. Until then, 7-3.